Thought I'd do a short video, try to keep it short anyway, on the CANFinder application that I have up on GitHub that I've been updating a little bit lately. And I'll explain a little bit about what it is and what it's used for, how it works. So the SLKCAN software, one of the things that it can do is write a log file that has the raw CAN messages just saved there. And one of the things that lets you do is update. You can go back to the same log and pull more information out of it when you learn more of the CAN messages. So as we know more about the protocol or the information and the different IDs on the CANbus, then we can come back through and say, hey, I learned this particular value. Let me update my code to parse this, and then I can come back to an older log I already have that exists, add more information to it, and use that. So it doesn't depend on the Arduino to do all of the processing on board and then save that to the log, or send it to a phone and have that do the logging. It actually saves all the CAN messages that it sees come across. So that file looks like this. I'm going to increase the font size here a little bit. So what you can see, the format of this is a timer. So this is a value that I think that's, I can't remember if that's milliseconds or microseconds, but it's one of the two. Anyway, this is time. This is the ID value in hex. So this is the CAN ID. For instance, this 19, just from experience, I know is the BMS data. This 8 right here is the number of bytes in the particular CAN message. So 8 bytes, these are the 8 bytes, D0, D1, D2, D3, D4, D5, D6, D7. So when you see me reference, talk about D0, D1, data 0, data 1, these are the data bytes that are in that one. So if you look at this one, 67, it has 1 byte, and so 1 byte is listed here. And this is the raw messages that come across the bus. And this is a pretty long file. There's a lot of messages that come through. The bike is talking constantly, so it picks up as many of those as it can. So I'll close that, and I'm going to show you the code logic first, or show you the program working first using that log that I took today. That log is from this morning. And then I'm going to show you how it works, and then I'm going to show you how to parse that into a CSV file that could be useful. So first thing to do is browse to where you saved your log file. So in my case, this morning, I have this one. That's the log I just looked at. So testlog.txt. Just click that. And we're going to press the load button after we've done that. And if the file is all formatted properly and there's no errors in it, I haven't had that issue yet, then load this. All right, what you can see here is the different ID messages. These are all the different IDs that were found in the log. An ID represents a particular piece of information coming across the bus, usually a device, but some, like for instance, BMS, I believe it actually has 2. It has this one, and then I believe their 619, I believe, is also the BMS. I'll talk about that a little bit more in a minute. So to start with the top one here. Now what you can see, now it's made this into decimal values instead of hex, and you can see it a little more clearly, but these are still not going to be necessarily obvious. So here's the ID again. The timing isn't shown on the screen. Here's the length, D0, D1, D2, D3, D4, D5, D6, D7. If it helps to have it in hex, you can click this button, and it will display it in hex and decimal here so that it makes it a little easier to see. And that's just the number base. It's pretty common for programmers to use a hex-based system. There's a lot of reasons for that I won't go into, but hex, decimal. Usually with this program, you can just stick with decimal. Now, these orange columns that you see, orange in the column here represents that during the log, of all the same messages, the same like IDs get sent over and over and over again as things update. It's just part of how the CANbus works. So what happens is these orange columns, those are columns that have seen some values change during the course of the log. So this particular message came in, let's see, 1,665 times or 1,671 times during this short log that I took this morning. Okay, so during all of those messages, the orange changed and then the other values did not. So if you look at the, I should have brought it up, but if you look at the document that I've shared on the group that shows the breakout of all the BMS messages, or all, not the BMS, all the CANbus messages, all my notes so far. That document may not be 100% accurate, but it's usually, it's as updated as the information that I have, put it that way. So what it'll do is it'll reference like D0, D1, D2, a particular word. So this value right here is the, I believe that is what I can determine to be a timer or something along those lines. This value right here is actually the battery SOC. These values here in the middle, I haven't seen those change, but I do believe it's still something from the BMS. This value, these two on the end, these are actually the amps. And what happens is it'll go from 0 to 255 in the first column. And then if the value is greater than 255, what you do is you take this column that has 1 in it now, you will multiply that by 255 and then add it back to the first column. And then that gives you a number that you can then divide to the proper units to get amps. And I think that was a divide by 10, but I'd have to reference my document to know that for sure. So that's an idea of how the data is stored in here. It does not, it's not obvious. So you have to actually figure out what all this stuff means. So I've done that for a lot of this, and you'll see this thing up here in the corner that says parse log. Parse log comes from where I have in the code for this application, I've gone in and coded how to get the data from these IDs using the guide that I made up, and then it'll take that and put it into a normal comma-separated text log to make it easier to use, easier to read. So let's do that. Let's press parse log, and I'm just going to go ahead and put in today's date, 04/19, and we'll just do video example.csv. I forgot to add in the auto file extension here, but just type in .csv at the end and it should work. And if you forget to, you can rename it afterwards. So save. You'll get a pop-up message that says done. And then if you go to that folder where you put that, you have this 2021-04-19 video example that we just saved. So let's open that. And here's your parse CSV file. And I just realized I still have a mistake that I haven't fixed yet. This one is actually going to be watt hours per mile estimate. So, and then what you have here is where that time value, it was actually converted. It's not actually converted. It's in the code recreates a new message based on each one of those timestamps that comes in, and it keeps a running tally of all the updated values and then puts them in this chart as every single message comes in. So you won't get every single value in this chart with every message that comes in, but it updates them on this spreadsheet as fast as it had them. So these timestamps are accurate to when the message came in. And then timestamp here is in seconds. So when you see me create the videos with the overlays, I'm not actually connected to a phone at that point or anything like that. what I'm doing in those cases is I will use this program. I'll convert it to a CSV file like this, and then I will import that into a program called DashWare along with my raw video footage, and then that will become, you have to go through some setup and configuration in DashWare to get all of that working, but once it's done, you have nice overlays. You don't have to do that. You can just leave it in spreadsheet form, and it's useful. You can do stuff with it. Now, you'll see a lot of things are 0 in the beginning for a second or so. And the reason for that is that that particular CAN message that updates that value hasn't come in yet. So, like the controller temperature, it didn't get that for 0.3 seconds. The what's this value? Battery voltage, which is a new value, put that in today. That is in 0x619. I'll show you a little bit about that in a minute. That means that it got that 0x619 ID. The first one that came in was at 0.41 or 0.4142 seconds. Let's see. Notice I don't have a battery SOC here. And normally that one comes in pretty quick. Oh yeah, I do. It's the first column. I was just looking at the wrong column. So the battery SOC, so with CANbus, the lowest value ID is usually the highest priority. It's just the nature of the way the bus works. It has to do with the way it reads in the bits and who has priority on the network. I'm not going to try to go too much into the details of the CAN hardware spec are sort of out of scope for this video. But this is the idea. So you come through here, you scroll down. Right here's where it picks up the 0x2DO, I believe, and this is the data that probably from the controller, and it has the odometer and the trip meter. That's what these two are. This is the gear meter. There's 23. The reason it's in this format is because I think the value, when the park switches on, it sets a higher bit in that particular byte. So I think it's 0, 1, 2, 3, and some higher bit. And so 23 means the bike is in park. You can look at the document that I've put up, and it'll explain what those are, what each number here, what it means. So there's that. What was 21 here? Controller temperature. So I fired it up in controller temperature. That's fairly recent too. But the neat thing about voltage is it's not something that's displayed on the controller. The other neat thing about voltage is that we already have amps, albeit heavily filtered amps from the BMS. So now we have amps and volts. We can calculate watts. So you'll see this bat watts column here. And if we go down far enough to where the bike actually starts moving, and you can see it, quite a bit of data here before that happens. There we go. So now you can see the wattage data, and it's taken into account the current battery voltage and the amperage instead of just a rated battery voltage that I was using on my first example. So that's really cool. This last value, I'm not entirely certain of my math here, but conceptually, this is supposed to represent watt-hour per mile. I apologize if you hear clicking. That's my ceiling fan, for whatever reason, has started. The little hangers are knocking together. But anyway, this is watt-hours per mile, and I'm not certain that there are times. At times it is correct, and then at other times it may glitch to a weird value when it gets close to 0. And the reason is that it stops updating at whatever value it had last there, which could be a little weird. So, but for the most part, it's pretty good. When you see it in the 50s like this, it should be pretty accurate. So that's useful, a useful value to have. And so in theory, we could calculate like if we could get a good average there, we could calculate the remaining range from the thing. So that's kind of neat. But I don't have that perfectly dialed in yet, so I think about that for a while. You'll see this percent SOC ppm, And what that is the, how do I put this? The percent SOC per mile. So every time this percent SOC changes, let's see if I can find a change here in the data. There we go, 84. So when this changes, what it will do is grab the trip meter value, and then when it changes, so in the beginning of the log, you might not see that do much, but it'll grab the trip meter value every time it changes, and then when it gets at least 2 of them, it'll compare the last trip meter value to the current trip meter value for that particular percentage change, and then calculate from that the percentage change per mile, so it knows the miles there. So that's sort of interesting. That's a kind of a useful parameter. In the beginning of the log, it's not terribly helpful, but near the end of the log, this is averaging. So this particular column here, average ppm here, that one by the end of the log, 3.9. And my bike, I seem to be, the way I ride it, now some of this is, fully admit, the way I ride it, I'm not super gentle on it. I did try to be a little gentle on it the other day and still got about 3.9 as opposed to like 4.4 I got on a previous log. But today, in the afternoon, I also drove it pretty hard and still got about 4. So I seem to be in that ballpark running in power mode all the time. At some point, I'll kind of switch into driving, trying to in eco mode and trying to be a little more docile in the way I'm riding, to see if I can improve my performance there. But honestly, I live close to work, so there's no real harm. And that's, when I drive right back and forth to work or around the neighborhood here, there's close by stores and stuff. So for me, the range of this thing isn't a super big issue, but I totally understand why it is for a lot of other people. And so, I'd like to provide as much of this as I can for the people who want to play around with increasing range. It is a handy thing to be able to do. So anyway, that's the log file. You got gear mode, which is the mode you're driving in, the percent SOC, the amps, the odometer, the trip meter, miles per hour, the controller temperature. This particular value, one of the bits in it has the side stand. And actually, I think the log parses that to a 1 or a 0. Yeah, it does. Okay, so 1 down to the side stand. So that's cool. Or I have to remember off the top of my head, but that will indicate the side stand. Percent SOC ppm, this is sort of like a live running value, and it gets averaged to give you the average ppm over the runtime of the bike. The battery voltage, which is cool, the battery wattage, and the watt hour per mile right now. Other values could be added to this. It does not necessarily need to be limited to what I know right now. I could go back and update my code, and after updating my code, rerun the script that generates this on the same log, and it would probably generate whatever else we knew. So that's kind of cool. Go ahead and save that. I don't think I made any changes, but just in case, we'll save that. All right, so there's that. So let's talk a little bit about this 619 that I found where I have battery voltage. This is battery voltage here, and what it is the same kind of thing where it this column. Let's see how this works. I believe it is this column multiplied by 255 added to this and then divided by 100. So I'll show you in the code in just a moment. So these two values make up the battery voltage. But if that's battery voltage, then this message is likely coming from the BMS. And one of the things I found interesting about that is you have this 74 here and you have the value of 26. So even though this is a 72 volt rated battery, that's close enough to this 74, especially since I haven't really seen mine get down that low, that they very well could put 74 in for the battery voltage, and 26 could represent the 26 amp hours of the battery. So that would imply that the controller knows the total watt hours of the battery. So that's interesting, because that amp hours times voltage here is how you get watt hours. So that's interesting. It means the controller knows that, is probably using it in some way in its SOC calculation. So that's kind of neat. I won't spend too much more time actually running the app here. Just wanted to show you that from what I found today. And go from there. So I'm not going to go into a whole lot of the details of how this app works because a lot of it's just looping through arrays and stuff, loading the values in, and all of that. What I will do is go over the interesting part, which is this section here. And very similar to the Arduino application. In fact, let me go ahead and fix that. Watt hours per mile missing here. Watt hour per mile. This is the header of the CSV file where it updates that. And apparently I didn't do that earlier. I did put the value in, but not that. Okay, so here's again, just like in the Arduino application, we have a switch on the value coming in. Excuse me. We have a switch on the value coming in. And then each value within that ID that's capable of being parsed is pulled out. And then this, you can see right here is where I'm doing that percent per mile calculation update. There's possibly bugs here. I don't think there is, but it's available for everybody to see. So if anybody wants to, think something weird's going on and want to look at the code, I did this quickly. I did that pretty quick just to see the data that's there. But anyway, from the BNS, it's pulling out the SOC, the amps, and then it's doing some logic here to calculate that percent sought per mile. So that's cool. This 619, see, this is where I'm pulling out that battery voltage. And you can see what I'm doing here is taking D3 multiplied by 255, adding D2, and then dividing that whole thing by 100. So that's when I see the 619 come in. Gear mode, when it comes in, that's 0xA0. When it comes in, I read it from D0, which is the only bit in that ID. And then the values 1, 2, 3, and 17 hex, which is 23. That'll give you eco, power, reverse, and park, which is cool, so you can see that's on there. 0x2D0, that is the odometer and the trip meter. These are a little bit of a funky calculation. One of the things about this is, let's see it here. I won't go over that right now, but essentially what this is doing is taking kilometer values and then getting the dividing it, converting it to miles. So it reads the kilometers from the bus using a similar method to above. 255 times D3 plus D2, divide the whole thing, which is kilometers, divide that whole thing by 1.609 to get miles. So if miles aren't perfect conversion when you see it sometimes, I'm only using 3 digits here. So that's a thing. But that's how it gets odometer and trip. And for the trip meter, it's a divide by 10 in here as well, just so they can have the extra resolution on that value. This is 0x101. It contains the speed, the sign stand value, and the controller temperature. The interesting thing about speed, when I read that out, I have not been able to figure this out. If anybody has a clue as to why they're doing this, when I read the speed out in kilometers, I have to multiply it by a value of around 1.275 to get sort of corrected kilometers, and then divide that by 1.609. This is where somebody member on the group probably saw me comment about seeing something weird with speed and it being offset. I haven't logged GPS yet in my data to do as a comparison, but I just thought it was really odd that there was this multiplier and then that was in there in order for it to match the kilometers shown on the display. So it reads this value out of the controller, which is, I just happened to come across when I was browsing data one day, and it seemed to match speed, except for it was off by a factor of about 1.2 something, and I'm going, well, that's weird, but it seems to work, so let me go ahead and fix it, offset the error so that it matches the display and the divide by 1.609. When I did that, it seems to be really well matching miles per hour, seems to be a useful speed gauge. So I don't know why that happens. If anybody has a clue on that, I'd love to know about it because I have no idea. Maybe I might be missing something obvious. Yeah, I don't know. I don't know why they're doing that. So, and side stand and controller temperature. Controller temperature in this port is D6 minus 40. It's just a direct minus 40 offset. So that's why it took me a little while to find that one, because I wasn't really sure why they did the minus 40. Probably just to get it centered in the byte better or something. And this is some bitwise logic here that just gets the particular bit that has the side stand value there to get that out. So here's where I'm doing watts. This is outside of the switch statement. So this happens all the time. It's always just comparing battery voltage to amps, whichever one of them's the latest, as it's getting the messages in, and it'll say battery watts is equal to battery voltage times amps. And this value is the watt hour per mile calculation. Nothing fancy here right now. The basic logic at the moment is if the speed must be greater than 0 and the battery voltage must be greater than 0, and then it will say watt hour per mile is battery voltage times amps over speed in miles per hour. So, yeah, take it for what it's worth. It could be better, but based on seems to be okay. So this section right here is where it builds it all into a single string that it writes for each individual row. So that includes the timestamp in seconds, the battery SOC, amps, gear mode, all the values that you saw in the spreadsheet file. So, this is in, I believe, Visual Studio 2019, the Community Edition. So this is a free edition of Visual Studio. It's written in C#. It has the forms designer. If my computer will behave. Take a sip while we're waiting on that. All right, so this is the main page of the app, and this is where all of that can be edited. So if somebody wants to download this and make their own modifications to do their own calculations to generate their own files, hey, that's great. And if you spot errors that I made, point them out to me. If I agree that it's an error, or if it's something that makes sense to me to change, then I don't mind doing that. So that's great. So yeah, look through it, see if it all makes sense to you. But this is available as is. If you don't want to install Visual Studio and have to deal with all of that, it comes in the debug folder. There's a bin file. It will ask you to install the .NET runtime libraries and all that's needed. So you'll have to do that if your computer doesn't already have it. A lot of Windows 10 machines and all already have it. But then it'll run the program just as you see it, when we push the button. This is just run. It'll run it just in this form, and you won't have the Visual Studio stuff to deal with. And, if I post a log or you want to see a log of my ride and say, hey, send me the raw CAN data for that, I don't mind doing that. I'll be happy to send you a log of mine. If you'd like to parse through it on your own without having to have the board connected to the bike, just to see if you can find something in there that you might be interested in. So I think this video is probably long enough. That's probably good enough for now. I hope at least somebody found it useful for understanding what this app is, what it does, and I will catch up with you guys later. Thanks.